Hello guys, I'm Samrat representing our design thinking class. I want you to imagine a situation that I'm very sure every student has experienced at least once. It's mid-afternoon. The sun is beating down on the campus and you walked into your designated classroom for a group study session or a lecture. You're ready to work, but the room feels like an oven. You look over at the wall where the AC remote usually sits, and surprise, surprise, the holder is empty. Our university faces a very specific and frustrating logistical challenge. Right now, there is a severe shortage of AC remotes. There simply aren't enough physical remote to go around for every single classroom on campus. To manage this scarcity, the university administration has implemented a remote versionizing system. Remotes are only placed in rooms that are officially on the daily schedule. If you want to use a room outside of those hours, or if the remote has been moved, you are stuck in the heat. The school does this to prevent a bigger issue, energy waste. In the past, when remotes were left in every room, people were, let's be honest, a bit careless. Students would turn the AC on, finish their work, and walk out without a second thought, leaving the unit running for hours in empty rooms. This created a massive conflict between student comfort and university sustainability. My group and I realized that the current rationalizing system was a barrier to our productivity. We wanted to eliminate the need for this rationalizing entirely. Our goal was to create an automatic system that stays permanently in the room, ensures the air conditioning is active when students are actually present, but most importantly, takes us on the responsibility of shutting it down the moment the student walks away. Our solution is the Fixed IR Automation Hub. This is a low-cost, high-efficiency device designed to be mounted directly opposite the AC unit, effectively becoming a permanent part of the classroom infrastructure. It completely replaces the need for a handheld remote. Technically speaking, the device is powered by a microcontroller paired with a PI or motion sensor. The logic is elegant but powerful. We programmed the microcontroller to act as a constant guidance of the room's climate. The moment the first student walks through the door, the sensor detects the motion and heat signature, triggering the microcontroller to send a burst of infrared code, the same code used by the original remote to turn on the AC. No more hunting for remotes. The room simply wakes up when you do. But the most critical feature is the heart of command. We program the system to monitor the room for activity. If the sensor detects absolutely no motion for a period of exactly 7 minutes, it concludes that the room has been wakened. It sends a final power off signal to the AC because the device is fixed to the wall. It is tamper proof and cannot be lost. You no longer need to ask a staff member for a remote or wait for a scheduled time to be comfortable. The room responds to your presence, making the entire campus more ready to use than ever before.
Three.
However, we're always looking for a way to iterate and improve. For version 2.0 of this project, we want to integrate a temperature sensor. Right now, the system turns the AC on to a default setting. In the future, we want the hub to detect the ambient temperature. If the room is already at a comfortable level, the device won't turn the AC on, or it will just adjust the setting to a standard cell temperature. Rather than letting it stay at a wasteful 16 degrees Celsius, this will add another layer of intelligence energy management to the system. Reflecting on this journey, it wasn't always as easy as it looked. Our biggest technical hurdle was the coding process. Finding the specific IR library and the exact hexadecimal codes for our school-specific AC model took hours of trial and error. We also had to figure out how to calibrate the sensor so that it didn't turn off if a student was sitting very still during an exam. But through this challenge, we learned that the most valuable lesson of design thinking, solving a problem isn't always about making things fancy or high tech. It's about making it reliable. We realized that by automating the off switch, we could bridge the gap between comfort and conservation. We truly believe that if this system were implemented in every class, it could save the university thousands in utility bills and hundreds of hours in staff labor. We have proven that you don't need to ration remote if you have a system that is smart enough to look after itself. Thank you for joining us on this project. And remember, innovation is about making the world a little cooler, one classroom at a time. Thank you for watching.